Every day, millions of shipping containers travel across oceans, railways, and highways, carrying everything from electronics and clothing to food and vehicles. One of their most noticeable features is the ridged, corrugated steel walls instead of smooth, flat panels. That simple pattern is not just for looks. It makes the container stronger, lighter, and better suited for the harsh demands of global shipping. In this video, we'll explore why shipping containers are corrugated, how the design improves strength, and why this seemingly simple pattern became an essential part of modern global shipping, right here, on History of Simple Things. A shipping container may look like nothing more than a giant metal box, but designing one is far more complicated than it appears. Containers must withstand enormous forces throughout their lifetime. They are regularly lifted by cranes, carried by trucks and trains, and stacked as high as 9 or 10 containers aboard cargo ships. During ocean voyages, they face heavy winds, powerful waves, and constant twisting as ships flex in rough seas. If their walls were made from large, flat sheets of steel, those panels would bend, flex, or dent far too easily under these stresses. Engineers needed a way to make each wall significantly stronger without dramatically increasing its weight. The solution had to be simple, durable, and cost-effective because millions of containers would eventually be built. Corrugation provided exactly that balance, transforming thin steel panels into surprisingly rigid structural components capable of surviving decades of demanding use. The secret behind corrugation lies in basic engineering principles rather than thicker materials. When steel is formed into alternating ridges and grooves, its shape changes in a way that greatly increases its resistance to bending. A flat sheet can easily flex because it lacks depth, but adding folds effectively creates miniature reinforcing beams across the entire surface. This increases the panel's stiffness while using nearly the same amount of steel. The concept is similar to folding a sheet of paper. A flat piece bends effortlessly, but once folded into an accordion-like shape, it becomes much more difficult to bend sideways. Shipping containers use this exact principle on a much larger scale. The corrugated walls distribute loads more evenly, resist dents from impacts, and maintain their shape even when subjected to immense pressure. This clever use of geometry allows manufacturers to achieve exceptional strength without making containers unnecessarily heavy or expensive. Strength alone is not enough when designing shipping containers. Weight is equally important because every additional kilogram reduces the amount of cargo that can be transported within legal weight limits. If manufacturers simply use thicker steel instead of corrugations, containers would become significantly heavier, increasing transportation costs across ships, trains, and trucks. Fuel consumption would also rise because heavier loads require more energy to move. Corrugated panels solve this problem by delivering greater rigidity with relatively thin steel sheets, allowing containers to remain both strong and lightweight. This balance has major economic benefits for the shipping industry, where even small improvements in efficiency can save millions of dollars each year. Lightweight containers also place less stress on cranes, trailers, rail cars, and ships themselves. By maximizing strength while minimizing material, corrugation helps make international trade more efficient, affordable, and environmentally responsible through lower fuel usage and reduced material consumption. One of the greatest demands placed on shipping containers is stacking. At busy ports and aboard container ships, containers are often piled several stories high with the weight of upper containers pressing downward. Interestingly, most of this weight is carried by the reinforced corner posts rather than the walls themselves. However, the corrugated side panels still play an essential role by preventing the entire structure from twisting, bowing, or deforming under uneven forces. They also help the container resist side impacts from loading equipment and shifting cargo during transport. Weather adds another challenge. Containers spend years exposed to salt water, rain, sunlight, freezing temperatures, and extreme heat. Corrugated steel maintains its structural integrity despite these harsh conditions, while allowing rainwater to drain more effectively than perfectly flat surfaces. Together with protective coatings, this design helps containers remain reliable through decades of continuous service across the world's busiest trade routes. Shipping containers became standardized after containerization spread in the mid-20th century. Common dimensions let boxes from different makers fit ships, trucks, rail cars, and storage yards around the world. Corrugated walls were adopted because they offered the best mix of strength, durability, and efficient manufacturing. Most modern containers use weathering steel, often called corten steel, which develops a protective surface layer that slows corrosion. Paired with corrugation, it helps containers last for decades with proper maintenance. Other materials, including aluminum and composites, have been tested for special uses, but corrugated steel remains the global standard because it is reliable, affordable, and easy to produce at scale. That combination made it one of the most successful industrial designs in modern trade. Its ridges symbolize the system that keeps goods moving every day. Shipping container corrugation is a simple design that solves a big problem. It makes the walls stronger, lighter, and more durable, helping containers survive the demands of global trade. Those familiar ridges are a perfect example of how smart engineering can turn an ordinary object into an essential part of modern life. Without this clever pattern, the global shipping system would be far less efficient and much more expensive. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.